Hey there, geometry people. Welcome to chapter or unit 9. We are using our book today. We are starting on page 103. And it's important that we use our book because the examples that we're going to be playing with, they're going to need us to use graph paper. So we're going to start off with a little bit of language of this section. This section is 9.1 and it talks specifically about transformations. And then we will eventually get to talking about reflections and rotations in the next few videos coming our way. So on page 103, we need to get a little bit of language understood. So you'll see that we have some things marked here in blue, and they're in bold, and they're italicized, which means they are important. And then they are summarized over here. A transformation is a change in the position, size, or shape of a figure. So you guys actually do transformations all the time. Anytime you're looking at a picture on your phone and you zoom in or zoom out, that is a change in the size and kind of maybe shape, because it gets bigger and smaller, of a figure. Position might be, well, a translation that I just did. I just pushed my chair a little bit further to the left. That is a translation of position because I kept the chair as a chair, and now the chair is a little bit to the left. Two more words that we need to get understood, and we kind of need to know these words. So this might sound bad. You've got to memorize it. You've got to know what these words mean. The pre-image of the transformation is the original figure. So pre-image is original. The image is after. So pre-image means before. Image means your final result. So on the bottom of page 103, we have a handy-dandy example that walks us through the concept of a couple of transformations. So check out this first picture on A. This is our pre-image. We want to know, what are we doing to A to turn it in to B? Well, let's take a look at some of the characteristics of A. It's 1, 2, 3, 4, 5, whoops, what's going on with my pencil lead here? 5 steps wide, and then 1, 2, 3, 4, 5, 6, 7, 8 steps tall. So a 5 by 8 rectangle. Oh, sorry, it did not autofocus lock. Hang tight. There we go. Well, this new picture, is that still 5 wide? 1, 2, 3, 4, 5. Yes. Is it still 8 tall? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so it did not change size, but it moved. Well, it had been sitting up here with a top of positive 10, and now the top is at positive 4. The bottom had been at 2, and now the bottom is at negative 4. Doesn't look like it moved right or left. It looks like it slid down. Interesting. So we're going to use words and, in just a little bit, symbols to describe this very first transformation. So from A to B, I think it's fair to say that this was a vertical translation down. Remember, we started at 10, we're sitting at 4, down 6. Now, let's talk a little bit about the concept of vertical versus horizontal. So vertical is going to be down and up. Horizontal will be left and right. So I'm using vertical and down to help your brain process that we slid this image down. Again, A is our pre-image, and B is the image. It's hard to write nice when I'm at the bottom of the book. Now, what's going on from B to C? Well, from B to C, man, that thing really stretched. It's still 5 wide, but it's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 tall. We'll compare that to where we had been. It was 8 tall. So now, from B to C, we're stretching up and down, so that's going to be a vertical stretch. Now, how much? Well, to go from 8 to 16, that's by 2. And if you were to say it stretched or it doubled, that would make sense. And I know this one just asked us to describe in words the transformation 1 was from A to B, but because we can still see the picture, I wanted to keep going. Because surprisingly, that's what number 2 up here on the top of the next page asks us, but we can't see the picture anymore. So hopefully we understand those 2 transformations. Now, I'm going to go back to that page and take a look at those pictures. This first transformation where we just slid our rectangle down on the page didn't change the shape or the size. It just pushed it, just moved it. This second transformation made our rectangle twice as tall. If we're going to have a move that is just up or down or right or left or maybe a reflection, think of like flipping something over, that is what we call a rigid transformation. It changes its location in this world, but it doesn't change the size or the shape. This guy that's stretched, that's a non-rigid transformation because the size or the shape changes. So that brings us to page 104, right there, where we're going to talk about the concept of a rigid motion. It preserves size and shape. So I want you guys to put a little side note underneath that this means that we are going to move up or down or right or left or any combination therein. We could reflect it. It's more like a slide or a movement. And then draw a couple lines and please write down non-rigid. Non-rigid is going to be maybe a stretch or a shrink. We are going to change the size or the shape. All right, so hopefully that makes some sense. So our next task is to start understanding things as we go point for point. And I'm actually going to do number 4 on the previous page because we need to be able to see the picture. So I'm going to come back here. I'm going to zoom out a little bit. There we go. And I'm going to use this space right here in the graph paper grid. So what I need us to do is I need us to create a 3-part table for part A, part B, and part C. Even with graph paper, I can't even draw a straight line. Goodness. We are going to write down each one of the ordered pairs for the corners of the rectangle on image A. So I'm going to start on the bottom left. It really doesn't matter where you start, just grab one and go. This guy, oh, now it's been a while since we've talked about coordinates, so I think I need to zoom back in. Let's have a little bit of an algebra review. Remember that your x-coordinate is moving right or left. Right is positive, left is negative. And then your y-coordinate is up or down. So to get to this bottom left corner, we have to move 1 to the right and 2 steps up. So that is going to give us a +1 and a +2, because right and up are positive directions. I'm going to take a look at the top left corner. We are 1 step right and 10 steps up. So that is 1, 10. Don't write too big or you won't have enough room. Top right, we are 6 and 10. So 6 comes first because it's the x, the 10 is the y that comes second. And then finally, the bottom right, we were at 6, 2. So just a little algebra coordinate plane review because it's probably been a while since you've played with that. Now let's talk about image B. And we want to be consistent. So I'm going to start here on the bottom left, and I'm going to come over to image B, and I'm going to grab that point from the bottom left. That is 1 to the right, but 4 down, so you're going to notice that, excuse me, the y-coordinate of B is negative because it went down. The next step we went to was the top left. We are still 1 right, but this time we're at +4 on the y-axis. Next step, top, computer was about ready to fade on me. Top right, we are 6 steps to the right, and 4 steps up. Bottom right, 6 steps to the right, -4 because we had to go down past the axis. Okay, let's knock out part C and then we're going to focus on what's happening with these ordered pairs. So image C, I'm going to start on the bottom left. We are at 1, -8. Top left, 1, +8. Top right, 6, +8. Bottom right, 6, -8. So our task, we understand how these images changed with these transformations, but our task is to be able to verify that what we're thinking matches with the ordered pairs. So I want you guys to take a look, ignore part C right now, grab my post-it notes because I don't want you to see that. I want you to focus on A and B. So what stayed the same? All of our x coordinates stayed the same. What changed? All of our y coordinates changed. Well, how did they change? From 2 to -4. Well, 2 minus what is -4? Well, let's go to the next one. From 10 to 4. 10 minus what is 4? I think the answer is -6. And I hope that is where your brain is going because we went down 6 steps. To go down 6 steps is -6 on the y-axis. So what's happening here as we go from A to B, what we can say, would help I guess if you could see that, when we go from A to B, what we're saying is that x doesn't change. What happens is the y is going to subtract 6. So notice how x and y, they're showing up there on A, like, hey, take your original points, write them down, graph them, do what you need to do. But then, to make our transformation slide down 6 steps, we're going to subtract 6 from the y coordinate. All right, next concept. Now I want you guys to focus on B to C. So what stays the same? All of our x coordinates stay the same. What changes? All of the y coordinates. How does the y coordinate change? Well, -4 to -8, 4 to +8, and then we repeat. That looks like it's doubling. So we could say, of course, they don't give us much room here. We could say that as we go from A to B, oh, I should not have written that. We're going from B to C. And of course, Mrs. Bishop does not have her whiteout. All right. Well, I'm going to put it up above. We're going from B to C. Well, the x and the y remains the same on B. What's changing? The y coordinate doubles. So we have 2y. So now we're starting to look not just at how our picture images change, but how our ordered pairs change, and the fact that we can now start to write it as a function. And don't stress, you're like, I don't really get that. Well, guess what? You're going to have a ton of other examples. So let's take a look at this guy down here. I move forward to page 105 so that we can see some additional examples and really start to understand how to write step by step a transformation with kind of like a formula. We're going to call it a function. So the original x comma y, this is our pre-image, the original picture we're looking at, and we have a nice beautiful square. I appreciate squares and rectangles because those are things that I can kind of somewhat draw. So this original square is denoted by x, y. We need to transform it based on the directions given. Well, these directions are saying x plus 3 and y. I don't know if the light is going to make it better or more of a glare. Let's try this one with the light. Okay, guys, let's start off with our pre-image of x and y. We're going to write down our points. I'm going to start on the bottom left and I'm going to work my way around. You can start wherever you want, but you just have to be consistent. Well, this guy is 2 steps to the right and 2 steps up. The top left is 2 right and 1, 2, 3, 4, 5. 5 steps up. Top right, 1, 2, 3, 4, 5. 5 right, 5 steps up. Bottom right, 5 to the right, 2 steps up. So this is our pre-image, the original. But our directions are saying x plus 3. Okay. Our task over here for our image is to take x plus 3. We're going to add 3 to each one of our x coordinates. So that means we'll be at 5, 2, and 5, 5, and 8, 5, and 8, 2. Let's graph that. 1, 2, 3, 4, 5. 1, 2, 3. Whoops, stop at 2. That's my very first corner left point. We'll be at 5, 1, 2, 3, 4, 5, right there. 8, 5, 6, 7, 8. Here we go. And 8, 2. Check that out. This is our image. Well, what do you notice about that image? Let's describe its movement in words. Sorry, should have been a Y up there on the top of that. Did it go up or down? No, because we didn't change any of the Y numbers. Did it go right or left? Yep. This is what we call a horizontal translation 3 to the right. This is a rigid transformation because we didn't change the shape or the size. We just pushed the box 3 steps to the right. So I'm hoping that is clicking for you. Well, let's take a look at part B. Alrighty, part B. This is our pre-image, the original picture. We have a lovely little rectangle. And the directions say 2x, 2y. Well, 2 times x, that's twice. So maybe this thing's going to double. So let's write down our ordered pairs. I'm going to start on the bottom left. I'm going to rotate myself through. So we are at 1, 2. We are at 1, 5, 3, 5, and 3, 2. So 3 steps right, 2 steps up. That's our original x and y. So now let's create the ordered pairs for a 2x and a 2y. We have to double them. This formula, this function is saying double things. So I'm going to double all of my x's and all of my y's, and let's graph this. So we're going to be 2 to the right, 4 steps up, 2 to the right, 10 steps up, so that was 4, 5, 6, 7, 8, 9, 10. Guys, we are at the top. Need to go 6 to the right. 1, 2, 6. Wow, look at that. Okay, so this got taller and wider. We have a horizontal stretch, that means the wider right and left, horizontal stretch of 2, so it doubled in width. We have a vertical stretch of 2, taller, and we would call this a non-rigid transformation because it changed shape. Changed size, actually. I shouldn't say it changed shape. It didn't do that. It changed size. It's double, double, double. So now the number 7 says, write the numeral 4 in the middle of each pre-image in item 6. So if I put the number 4 in here, how would the shape change? When I move up here on part A, over here, will the 4 get any bigger or any smaller, or is it just moving to the right? It's just moving to the right. On B, whoa, Gigantor 4. So that 4 on the inside, it's going to have the exact same transformations. It's going to be double wide, double tall on B. On A, it just moved to the right a little bit. So I'm hoping very much that this is making some really good sense to you. Didn't realize this video was already pushing 20 minutes. So your guys' task is to take a look at problems 8 and 9 and 10 and 11, and I think you guys got this. Oh, let me give you a little hint on number 11. Y over 2. Gosh, I wish you were in the room right now. Y over 2, dividing by 2. Hey, cut the y numbers in half. There you go. That was section 9.1. As always, let me know how I can help.